looking at note page 222, kinetics and equilibrium, looking at the last two example questions. So here we go. So we have a system at equilibrium, and we want the equilibrium to shift right. So that means we want it to shift to the right, and we are identified that the stress is a pressure and it decreases. Okay, so let's see if we can eliminate any of the responses, because we have two criteria for pressure to be a stress. So number one, there has to be at least one gas present in the reaction. So when we look through all of our reactions, okay, every single one of them has a gas present. So every response meets the first criteria. The second criteria is that you have to have unequal moles. Okay, so when I look at response 1 plus 3, I have 4 moles compared to 2 moles. So response 1 could be an answer because gas, unequal moles, right? So I'm going to just put unequal, so that checks out. Okay, response 2, when I look at the reactant side, I see 2 moles, and on the product side, I see 2 moles equal. So the amount of moles equal, response 2 we can eliminate. Okay, now response 3, how many moles of gas do I have on the reactant side? 0 moles on the reactant side compared to 1 mole on the product side, so that represents an unequal number of moles. So we have a gas and we have an unequal number of moles. And then looking at the last response, we have 2 moles on the reactant side and we have 2 moles on the product side, equal moles. Pressure's not a stress for system 4, so we eliminate it. Okay, so now here we go. So we know that in response 1 and in response 3, we have at least one gas present, unequal moles, so pressure is a stress. So the next thing that I want to remind ourselves is that number 3, that when you drop the temperature, the system will shift from the lower side of moles towards the higher side of moles. So that means in response 1, we have 4 and 2. That means it wants to shift from 2 moles to 4 moles. So that means that this system wants to shift to the left. When we look at system that's represented in letter or number 3, we have 0 moles compared to 1 moles. So the system shifts from the lower number to the higher number. So that means that this system will shift to the right. And our final answer is our choice needs to show the equilibrium shifting to the right. So best answer for this one is response 3. Okay, last example question is coming from things we've seen on the part 2 of the Regents exam. So we're given a system at equilibrium. So here's our system. Identify changes or possible stresses that will decrease the amount of NO formed. So decrease the amount of NO formed. So this is the result of the shift. So if we want less NO, do we want to shift towards the NO or away? So we want to shift away from NO. So we want the system to shift away from NO. So that means we want the system to shift left. So we have to identify possibilities. So we want the system to shift left so that this is fused. So let's think through the processing. Well, number 1, we could remove or decrease the amount of a reactant of N2 or O2. So possibility number 1, so decrease the concentration of N2, or you could say decrease the concentration of O2, or we could go more general, decrease the concentration of a reactant. So dealing with concentration as a stress. Number 2, we could talk about the idea of heat. So we want to remove heat from the system, so we could say decrease the temperature of the system. So the stress would be us manipulating the temperature, and when we manipulate the temperature in the system, we are manipulating the amount of heat. So we want to decrease the temperature because we want to force the exothermic process to occur. So decrease temperature because we want the exothermic process to be favored. So now we've talked about manipulating concentration, manipulating temperature, and our third major stress is pressure. So let's take a look. Could we change the pressure of the system to make it shift to the left? So when you think about pressure, okay, so you have to have a gas present, and we definitely have gases present, but besides having gases present, we have to have unequal moles. So take a look. We have 2 moles on the reactant side and 2 moles on the product side. So write yourself a note. So I'm going to write this in red. So pressure is not a stress. So we can change the pressure of the system, but it will not make it shift to the right or to the left. So pressure cannot be used as a stress because there are equal moles. So the change in pressure does not favor one reaction over the other. So in this question you have to identify decreasing the concentration of one of the reactants or decreasing the temperature, removing heat to favor the exothermic. So watch out. Pressure, you have to think through the process if it can be a stress.